Yes, please. Unless anybody's got a question, then just have it muted, and then we'll
I don't.
keep
So
noise to a minimum. Yes.
okay, what that also means is that Ramon, you're gonna, if somebody needs to tell me something, you field that question for me somehow, because I won't have a way, because I'm gonna just have my screen doing this, so I won't have a way of seeing any the chat or anything like that.
Great.
So
We won't need the chat at first, so that'll be good. So we're just going to go through the slideshow.
yep.
All right, everybody ready? Very good. And so welcome everyone. Whoa, we've got there we go. Great. So thanks for joining, guys. I created this slideshow yesterday. It dawns on me that one of the biggest difficulties is that when it comes to understanding the plasma electromagnetic cosmology, and we're not covering really much of the extended stuff. I'm sure the Q&A is going to get wild, but the problem is that most people have been given an incorrect narrative about the history, and then we have the wrong chronology. And what happens is people try to filter the phenomena they see around a lot of different aspects of the universe, and then somewhere in there the wedge is plasma, and another wedge is electricity, and another wedge is magnetism. So in plasma electromagnetic cosmology, we really want to eliminate that effect. And so the best way to do that is go right back to, comparing it versus a Big Bang cosmology. It's kind of ironic. Both of them got their official start in 1927. It was the first time that in 1927 that Langmuir actually called it cosmology, but people had been doing work on plasma for over 25 years, and but that was also the year that we had the presentation by, I'm going to butcher his name, the priest Lemaitre. I'm sorry, I'm probably butchering that. But anyways, he was not a scientist per se. I mean, he was in the science, but he was a theologian. When that was presented, Einstein at the end jumped up and clapped for it. It had not been tested, so it was literally a response to some mathematical aspects about general relativity and the presence of some radiation in measurements. Robitaille has identified those signals to be really actually oceanic signals. So we probably won't get a lot into that, but all right, let's hit next here. So we're going to have 3 slides of grounding knowledge. First of all, electricity as a word goes back to 1646. So when you hear people say that Benjamin Franklin discovered electricity, that is not quite accurate. What is accurate is that he discovered that lightning phenomenon was electricity. And fun fact, he wasn't holding the kite. He had his illegitimate child hold the kite while he stood on a rubber mat. So he had some inkling of what was going to happen. But Gilbert's De Magnete came out well before Isaac Newton. So if you think about this, Isaac Newton, who was a seeker of mystical and mathematical knowledge and was fascinated by optics, when he was formulating the concept of gravity, he would have had his own personal copy of De Magnete, and he would have read it in the original Latin or Portuguese. He would have understood that there was a mysterious phenomenon. What he lacked was any kind of model for which he could explain what gravity was. So when he came up with his equation, he had no idea later on that electricity would be described using basically the same equation with a different constant. All right, so if Newton were alive in the 1900s, his idea, he would have abandoned that idea and actually adopted Maxwell's equations. And that's a really important point that people on the other side, they're never pressed on that issue. So I'd like people that's one of our major new pressing points I'd like people to make. He would have revised all of his work and probably he would have taken the calculus and refined it even further. And of course, Heaviside did, and simplified the Maxwell's equations. And then there was a man who was a mathematician named Henri Poincaré. I don't know how to say the French. I don't speak any French. He actually came up with the concept of relativity theory, and he came up with the concept of gravity waves. He did Lorentzian transformations of Maxwell's equations. He was not the one who came up with the mass-energy relationship. However, he first described it, and it was described as, in terms of mass, as E divided by C squared, implying that he was trying to find a definition for mass, which has been abandoned because now the definition has been for energy. When you rearrange it, it seems like Einstein is focusing on what is energy, but the original work was all focusing on what is mass, which leads to obviously the question of what is inertia and weight, and it seems related to matter, but the mass-energy relationship shows that instead there's a relationship between the actual energy contained in the system, which is a real value, divided by this constant C, which some people are describing as the rate of induction in the ether. I don't think that we know exactly for sure that that's true, but I think that it's not a bad definition, and I kind of go with it. But special relativity itself, which came out a few months after Poincaré's relativity paper, special relativity paper has zero reference to gravity in its equations. So there is no G in that equation. What there is electromagnetic propagation. And time, of course, time and length, dilations. Okay, next slide. All right, so Einstein's Nobel Prize was in 1911 was for the explanation of the photoelectric effect. He did not discover the photoelectric effect. This is an important point. Ironically, that year, Rutherford's atomic model was accepted. So I'm not sure why he didn't win the Nobel Prize in physics, but it is what it is. The photoelectric effect was discovered in the late 1800s. It gave him a rock star-like status that later his students used up to prop general relativity up. But at the time, if you were a student in that era, general relativity was not accepted. It was not a valid theory. It described nothing. It talked about a one-body universe and something about fantastic clocks in space. It wasn't science. And the quantum field was much more developed. There were dozens to hundreds of scientists in the quantum field, and they looked down on general relativity, as well as, of course, Nikola Tesla. The gaseous sun was an invention in the 1800s that went back to spectroscopy, because in spectroscopy, in the original spectroscopy, you burned materials, and especially gases, and then looked at their spectra to compare them. If you look at how stars are categorized, they still have a throwback to that system. And as they would discover new types of star spectra, they would invent new spectra labels. And in fact, that was primarily a woman's work. She actually, I don't remember her name, but she actually is the one who came up with that categorical system that is still in use to this day. But the atomic model did not even exist at the time that the sun was decided to be a hydrogen gas ball. All right, so there was no plasma in the discussion, and there was no atomic model. Now, of course, atomism has been around for thousands of years, but it hadn't been proven. The gaseous sun was turned into a fusion sun during the quantum revolution, and the spectral signatures were provided as the evidence, as it was the only way that it could be done. But fusion itself has never sustainably been reproduced in the lab. You have plasma fusers, you have momentary fusion interactions, but you've never had a gravity-driven fusion experiment. And using lasers is ironic, because lasers are electromagnetic, so they have nothing at all to do with gravity. Next slide. So fusion is now researched currently, and this is no joke, with plasma, electricity, magnetism, and EMF in terms of radio waves and lasers. Thermodynamics forbids any system to perform work upon itself. That would be called over unity. And for gases to spontaneously compress, collapse, this would increase the heat of the gas. So that's forbidden as well. Flat out, there is nowhere anyone would argue. So if you went back to Lord Kelvin himself would agree with you. But in the next sentence, he would support the gravity-driven sun. He wouldn't know anything about fusion because that wasn't his era. But he would be in support of a collapsing gaseous star because they had no other means at that time for how gas would stay together. They did not understand the electromagnetic phenomena enough, especially in space. Bear in mind that at the time that these arguments were happening, at the turn of the 18 to 1900s, the general thought among astronomers, if you could call astronomy a science, was that the universe was not much bigger than the solar system, and that the Milky Way was the only galaxy. So think about that. At that time they thought it was the only galaxy, and they did not know that that the solar system was one part of that galaxy. 99% of the observed universe we know now is plasma, and the remainder is antimatter gases and solids and fluids. Most of that plasma is contained in a dark mode or low glow mode in cosmic dust, and it is not in an active arc mode or in a very high glow mode. But there are portions that are, and up till now they've been using a gravity-driven system to define that behavior. When Alvin created magnetohydrodynamics, he had to leave out the electric forces because mathematically, if you go and you look at Maxwell's equations, the magnetic equations on the left usually is contained are much simpler equations with fewer variables, and then the electrical equations are much more difficult. And this is an era pre-computers, actually, pre-anybody having computers. We're talking around the time when they were building the Turing machine and Korea War. Quantum electrodynamics, similarly, in that time they began that work, they could only put the electrical forces in a single dimension, whereas the magnetism, they had it in 3 dimensions. But Birkeland currents, we now know, of course, are 3-dimensional. So the work of QED is not complete, and probably not going to make any major revolutions because most of the top minds in that seem to gravitate towards quantum chromodynamics. But that's probably another story. Next. All right, so let's compare the 2 cosmologies directly. So plasma is an ionized fluids and solids, which are also conductors. So gases, crystals, and ultra cold basically condensates, forms of condensed matter. It's rather mysterious. It's outside of my area of expertise. Electricity is self-evident. We're using it right now, but power has been found in DC and many forms of alternating current, as well as signals. I would say that signals probably comprise at least 90% of the universe's form of electrical power, how it's being propagated. And you only really detect those signals with an antenna. There's a lot of surface antennas. Your body is acting as an antenna. The wire going to my phone is an antenna. Your keyboard wire is an antenna. But the wavelength that you will interact with that, it's called a quarter wavelength. That quarter wavelength may not describe anything useful or relatable. So most of the time the signal is lost. In fact, the biggest revolution in electricity that we can have on the surface of the planet before we go into space is to capture signals and convert the random signals into power source. So we'd have to design a power transformer that could capture signals on a super broad spectrum and then capture enough of them and convert them into one single phase of power. That's why no one's done it. Magnetism does not actually flow. you'll see the idea that it flows, and we know that it does not flow for a simple reason. If you have a permanent magnet sitting still, not only does it not move the filings, but if you put a coil of wire around it, there is no electricity generated. You have to change the magnetic field either by moving it, or if it's an electromagnet, then you can change the voltage and it will change the electric field. And that changing electric field will generate the electricity itself. So that's a big difference between magnetism and electricity. We describe magnetism through a flow because it is a convenient model, in much the same way that photons are described as a particle, but they are not a particle. The force, the unified force, is much larger than all of the descriptions that we currently have. Now, by comparison, most of you guys know this, gravity is 10 to the minus 39 times weaker than plasma electromagnetism. Mass is not a defined concept in Newtonian mechanics, and for that matter in relativity, mass is not defined. It appears to be tied to matter, and I agree with that because matter contains energy. Gravity varies with different surfaces. So the idea in Newtonian mechanics is a vector base. There's no description of how those vectors are interacting to actually transfer the energy that is required. Gravity waves are the way to replace that. But when you actually look at the surface of a planet, you get variable gravity on that. And we have some evidence that the electrical scarring, say on Mars or on the moon, actually changes that even as well. There might be some issues with saturation in our satellite measurements, so probably we don't have a full picture of that. But there are some regions of Mars that are excavated with higher, that appear to have higher gravity rather than to have less gravity. And if it's saturated, then it's probably not saturated to the bottom. It's probably saturated all the way up. Gravity at the center of the Earth, you always hear that there's crushing gravity at the center of the sun or at the center of the Earth. Well, there might be crushing pressure, but gravity will be zero. And you can calculate this with just basic spherical geometry. General relativity has no accounting for any of these stronger forces, such as the electro and weak force, which are now combining the electroweak and the strong force. Gravity is not conductive, of course, and it only attracts, it does not repel like electromagnetism does. So there are some differences. All right, next. Okay, some of the things that we can see about plasma electromagnetism, which makes it unique, is that it can be divided into many different effects, which seem unrelated to each other. And this is part of the problem, is that you can go in, you can study one thing. Like if you are an expert in the strong nuclear force and you get interested in atomic forces, you'll probably know about van der Waals forces. But how that is related to bioelectricity is not understood. But clearly they must be related because a gecko uses both. A gecko has bioelectricity in its limbs in order to control on will the molecular behavior in its skin to actually split and split and split to small enough level to interact with the van der Waals forces inside the molecular boundaries. And that is a very strange effect that we do not really understand. We're trying to replicate it, but that doesn't mean that we understand. And in the answer is, of course, going to be in the study of bioelectricity. You can read through most of these. Superconductivity, we have a description of it, of zero resistivity. It's actually in the billionths of ohms in terms of resistivity. But we call it zero resistivity. That's a way of hand waving. We don't actually understand superconductivity, in my opinion. There's only one major model that's used, but yet we keep finding higher temperature superconductors. Within this 100 years, I can make the prediction, probably within the next 50 years, that we will have superconductors at room temperature. And just let that sink in. If you've ever watched superconductors, it's sort of like a permanent magnet in that interesting repelling behavior, but it locks in. And that locking in is a very predictable behavior, and it repeats, and it costs no energy to the system. So how is that working? Or it is costing energy to the system, in which case, where's the energy coming from? Because gravity is still pulling down on that magnet as it's floating above the ceramic. Of course, everybody knows about a lot of these other properties. Hysteresis, one of the more interesting ones that Steinmetz was able to first describe, and in his huge works, which are over 1,000 pages, which is basically describing a memory of the electric and magnetic effects inside of, say, copper. And we primarily worry about it in electric motors and generators, but it's actually present in all the electromagnetic phenomena to some degree. Condensed matter behaviors. So condensed matter physics is its own branch. I think you kind of have to be a weird guy to go into study. I mean, nobody enrolls in physics, I think, specifically to go into condensed matter. Like plasma, you got to kind of get interested in the subject, and that would include the liquid metallic hydrogen. There's crystal properties to plasma, but there's also just generally crystals. And I think most people in here understand crystals have a circulating lattice of electricity, which is going to generate magnetic fields. So there's a propagating field coming out of that crystal. Cavitation, I know, but one of Buddy's favorite subjects. How is it that something moving at a certain above the speed of sound through a medium is able to generate a super high temperature? Of course, Robitaille would probably say that that's a reading of that temperature, not necessarily the actual physical temperature. It's very difficult, of course, to get a probe into those bubbles and the kind of speed that they appear and disappear. To make gravity more interesting, therefore, when you compare the two, the people in the cult of Einstein, they basically invent a lot of their own aspects. So you have space-time, which comes with beautiful, invisible, and fantastic clocks that have nothing. They're thought clocks. They're pure philosophy. They don't exist and have never existed. To replace that, they've introduced quantum clocks and satellites. However, they can't prove that those satellites aren't influenced by the Earth's electromagnetic field. So how can you then therefore isolate to prove general relativity? Because general relativity, there is no electromagnetism inside the equations. So there's a huge problem. K curvature, which of course everybody has recently learned that by satellites, yes, they do have to keep adjusting the clocks. Yes, they do. The K has not turned out to be constant at all. So that's a huge lie, and we've got to call them out on that. And I'd like for people to put the feather in the cap on that for when they have a discussion with anybody who's on the outside. Of course, I've already mentioned that Big Bang itself, invented by a priest. The cosmic background radiation disappears using the Haruni dish shape. That paper is available on the plasmaeducation.net and on Sky Scholars channel if you can find the video. And then black holes themselves are a byproduct of the mathematics of the singularity. They have a radius of 0, mass of infinity. They're a single body, and they describe nothing in our universe. And they are also, of course, as you know, classically, nothing can leave, not even light. That's the entire point of calling them a black hole, but they are an object rather than an actual hole. So when we talk about the toroid, we got to help people to distinguish between uppercase and lowercase hole, because here it's supposedly an actual object, but mathematically it is not an object. It is a pure concept, but that concept is based upon derivations that have to do with a single body system. People can refer to Crowther's Destroys the Quacademic Black Hole, where he goes through that math. Next. And of course, the classic black hole has been completely debunked. There are no classic black holes. Everything's coming out of black holes, right? Your mama's coming out of black holes. I mean, everything is coming out of black holes. There is no, it's almost unbelievable, all the things that they've hand waved to be coming out of these black holes. All right, now plasmoids were a term coined by Bostick in 1957, a full 10 years ahead of the black hole theory. And so they were the result of electrification. They're purely seen in lab. You can generate plasmoids yourself with the right equipment. They're probably found in nature. They might be UFOs. There could be plasmoids at the center of planets, including our own. But the main thing is that for whatever reason, plasmoids did not become a household word. And I'm not sure why. I mean, on account of that plasma is interesting. I think it has to do with the star status effect. People were looking for a way. I mean, it was an era where quantum physics, the weirder you were, the better. You know, I think that's one reason why, you know, the daggone cat, the short, what was it? Somebody help me with this. Starts with S. the cat, the dead cat. Daggone it. Schrodinger's cat. Schrodinger's cat. You notice it's not called de Broglie's cat because de Broglie is, I mean, is just not a very well-known fellow outside of the quantum circle and in certain physics classes. He didn't achieve that rock star status. And that is, like it or not, the way that you recruit your next generation of pupils. Now, if you fast forward, you think about 1957, not only have you been post World War II and you're at your post Korea War, at the beginnings of the Cold War being stronger, but also this is the beginning of the quantum revolution era where they were finding a particle a day, sometimes 2 particles, 3 particles a day. And also this is 3 generations removed from the 1927, 4 or 5 generations removed from Einstein winning the Nobel Prize. So you now have the students of the students of the students, and then their students too. Now you're getting to a legendary kind of cult status. Plasma has very unique nonlinear voltage current curves. I was just watching a new video. I definitely recommend, not new, it was actually 2014, but it's a little rarer in our community, where the chemist for the Sapphire project is showing a little bit of under the hood. And I posted that video. If people need the link afterwards, I'll try and find it again. But he was showing some of these voltage current curves, and they don't follow some of the simple behaviors that you expect in a fusion gravity environment. The sun demonstrates these very properties. In fact, even in those early days of Sapphire, when they would turn the probe away from the anode and face outwards, they would find an acceleration, and in their world, acceleration meant a temperature increase facing away from the probe. This is not really contested anywhere. Markland convection and Bennett pinches are phenomena consistently observed and reproduced in lab, and they are seen in space. Plasma double layers have massively variable behavior, fire, lightning, atmosphere, all sorts of different kinds of plasmas. Earth has massive current surrounding it. I can barely read here because of the little heads popping up, but between, I think it says 100 kiloamps and 3 times 10 to the 9 amps for the Van Allen around the Earth. You saw that these currents were first proposed by Christian Birkeland in 1903 when he was observing the North Pole. So there's nothing, I would say, weird or non-standard science. Quote, Professor Dave makes it sound like we're talking some hokey pokey here, and we're not. It's more standard than he is. The plasma term itself is coined by Langmuir in the early 20th century. I didn't look up which year before this. These are not controversial things because planetary terrellas have been used in experiments all the way from Gilbert's early days through Bostick and Alvin to try and recreate planetary phenomena. In other words, another way of saying this is when Benjamin Franklin was discovering electricity, so-called, most of the people at the time would have likely thought of the force that binded the universe as electromagnetic. Now, they might have argued electric, they might have argued magnetic, but they would probably not have described it as a gravity phenomenon. At this same time, it's important to point out Houghton Arp was discovering that redshift was misunderstood because he was observing directly connections of plasma bridges between quasars and their host or mother galaxies. This ejection method is not yet described, but I would imagine some form of lattice exclusion or maybe a cellular division kind of activity. We don't really know because they won't study it and produce
electrical
the
overstretching.
result. It could be electrical stressing, repulsion. There could be some form of electrodynamic effect there that it's a lot like electrostatics. We don't know. And it will take a lot of work, and NASA would have to devote some of their resources, which would mean they'd have to stop begging for dark matter grant money. Next. All right, so on the right there are some of the actual measured, and of course in the paper that debunks the magnetic universe only idea. These are the current measurements that are actually measured. They're from standard papers. Every single one of these currents is a citation in the paper. They're not showing here on account of the footnotes are removed by the copy pasta. And they go from the smallest down at the nerve conduction all the way up to the highest. The electricity in a plant is not really a paper. I do have to mention this, that comes from the presentation that was, I forget, it might have been Bruce Laybourne. I can't remember who gave the presentation at Electric Universe Conference, and he had actually been measuring and sticking probes in his tree, which made his wife unhappy. But the rest of these are excellent descriptors of the current scales, and what you'll notice is going from the bottom up, nano is 10 to the -9. They go up in scale, and they also go up in scale and size. And if you cross correlate, which I haven't done here, as you go up in scale of the current, you also go up in scale of the velocity at each of these is moving in the universe. And I haven't gone to compare Earth's velocity around Jupiter's velocity. Maybe somebody can do it in the background while we're doing this, but I would almost bet you that Jupiter is moving at a higher velocity around the sun than the Earth is, even though it takes longer to get around. So electric currents in space are not controversial. Again, this Professor Dave character doesn't know what he's talking about, which is why he got so mad when I posted the Wiley textbook, which I recommend people purchase, the Electric Currents in Geospace and Beyond, published 3 years ago. It's a standard textbook full of papers not by Donald Scott. And there are connections between Io between Io, Jupiter, Enceladus, Saturn. The Van Allen belts are now known to be electrical measurement. We have those measurements. The solar wind itself, black holes even have electrical. We have those measurements. We have measurements from active galactic nuclei and quasars. There's an entire paper actually where they question whether or not black holes should be reconsidered about their charge being neutral, the charge itself. And so I think that they're starting to understand that they're not looking at even remotely a singularity. Of course, they have a multiplicity, so I don't even know why they bother call it a singularity. It's a word that probably should be struck from the English lexicon. All these are absolutely measured. They're not purely calculated. And electricity does flow. It has a measurable flux. And this is an important factor. It is true that we have a hard time finding all of the electricity that we're expecting when we send a satellite over. But let me ask you this. If you send a flea over top of a giant bowl of stew, is it going to get really a good idea of the volume of steam coming off of that stew, or is it just going to know that it's hot? And so sending a single probe over top of Jupiter or Io is not going to solve the issue. It's only going to give us the basic taste of what's happening there. Next. So these are the two books that are definitely recommended. And you can tell this to people, electromagnetism is the old OG, not gravity. And in the very first paper of that Electric Currents in Geospace Beyond, it has the full history that goes all the way back to that 1646. It also mentions De Magnete in that, so Gilbert's own book. And it comes forward, and you can see that very astute and important men in the Enlightenment period were studying this. It was never fringe ever, and it never has been fringe the entire time. Next. So other resources people can refer to, of course, those names on the left. I definitely love the Hawkins guides because they come out in the same year in which the photoelectric effect was being explained. So you get an explanation of electricity and magnetism, which is not touched at all by either quantum or relativistic new age hibbity-jibbity, right? It's put in terms of power and potential and tension and the words that originally were used at that time. And the diagrams are beautiful. They're hand drawn, well, not hand drawn, but they're kind of lithographs. And then, of course, I do recommend the Jurgens Scott model because it's only so far the best one. Sapphire is, of course, going to throw that under the bus. And, you know, if Eugene has his way, then that'll get thrown under the bus too. And we'll just put it all together into one big model. But Sapphire is doing something really important in that it's isolating a variable, in this case, mostly the anode and the electrical behaviors. And that's important in the experimentation process. So the key things to remember here, and let me see, I got to turn my phone so I can actually read these. So we don't need a thing in the center of these black holes. They're just toroids, such as M87 and SGRA. And their electricity is fully scalable. It's far stronger than gravity. It's been measured emerging from the AGNs. Plants and animals are found to interact with electricity and magnetism routinely. And that's turtles, birds, fish, humans, everything. They've even found electrical effects that spiders on their spider they're releasing the silk and along electric currents, basically electric field measurements. And then they're using that to actually ride across, because otherwise you can't just use wind. They can't just like, oh, you know, feel the wind and then shoot their web across. Einstein avoided using electromagnetism because Henri Poincaré did it first. So if he had used electromagnetic descriptions to derive his general relativity, he wouldn't have been given the credit that he so desired. So when people say general relativity works so well, my argument would be, well, because probably relativity works really well. If someone were to go back who had the capability of a Crothers or a Poincaré and did the tensor equations from Poincaré's work forward, we would probably find the actual general relativity that works. And I think we'd need to call it something new. So we'd have to come up with a really classy name, and just nobody's proposed to do that because there's no Nobel Prize in it. So there's no reason for anybody to do it. There is no accounting in general relativity for the electromagnetism. The measurements of all stars and celestial objects are done with optics, which means they're using EMF. They're using EMF spectra. They're analyzed with electrical devices measured against values based on quantum masses, and they're all measured ultimately in electron volts. So color me this. Why does gravity have anything to do with any of those things? All right, hit next. So let's see about the other side. Right, so general relativity and black hole theories are completely incompatible paradigms with Big Bang. And Big Bang is, of course, the big daddy that has to be dealt with by plasma electromagnetic cosmology on account of it's the one that's more observed. They are not mathematically, conceptually, or mass-wise compatible theories. They do, because Big Bang people do measure electricity in space, but they feel obligated to prop up general relativity because of some relativistic, especially the special relativity effects are observed, just not all of them. Relativity was first the Lorentzian transformations of Maxwell. And like I said, it would be probably better if K values, if the tensors had been done on Maxwell's equation directly, and then we would have some effect of which electricity and magnetism interact would explain variable gravitational constant throughout the universe, because then we would see the plus and minus of the gravity of the electricity and the magnetism. Newton and Mond are completely incompatible with general relativity and with modern observation, so you can't go backwards. let's see here. Nevertheless, the modelers rely on Newton and circular reasoning to prove space-time exists. They rely on art, and which art should always follow the science. You surely can have art in science, but you can't have art determine science, which is unfortunate because it happens all the time. The European Space Agency put out a video where they basically made it into magic, and they said that they were going to find all this water and it was going to change the world. And they hyped up this satellite and they got to the comet and found none. And I'm sure Rick knows the exact name of that comet. I'm trying to remember the name of that comet. But they found no water at all. And so the video was extra, I think, embarrassing, especially you go and you look at the comments and the YouTube, and new people who don't know that's in the last few years, they watch that and they get hyped about the project. They get hyped about the video. They talk about how great the production is, but no one has told them that that project is completed and they didn't find anything. So, rather egg in your face kind of situation. The sun has over 50 proofs that it cannot be gravity collapsed. Black hole theory is merely an extension of the gravity solar fusion, but ad absurdum. General relativity predicts lensing beyond r equals 1. It's never been found. Of course, most of you guys know about Edward Dowdy. It should also predict many other types of lensings to occur, including within our own solar system, right? There should be some measurable gravitational lensing around the sun beyond its first level of radius, and that's never been observed. Almost all the observations of lensing are almost certainly user or equipment error, or just basically refraction. You're looking in a linear direction at a certain star, and you're looking, and there's another object in the way, and light is bending around that. Almost certainly, it is just the light that is being refracted through the plasma, the magnetized plasma around the atmosphere of that object. And I feel like I'm taking crazy pills to have to say that, because that should be the first, in eliminating variables, that should be the first thing astronomers think of in the elimination of that variable. Next. All right, so here's the video, and I'm going to shut up and let this thing play. It should play automatically. Okay, well, he's obviously talking about the model that he's using here. So let's just watch here as he puts the masses on his stretchy thing. Oh, there goes one. Oh, look, it crashed right into the star. Genius. Okay, and he's going to put another one here. He's convincing all these students that the curving of space-time is replicable here, and this is why gravity works, is that the curve time has bent, and the marble therefore has to go. Obviously, everyone of us understand things roll downhill, but he's speaking to people who are leaning upon his expertise. Oh, look, he'll put it in orbit here. He's going to put it in orbit, and let's see if it can stay in orbit, a stable orbit. I've not seen a stable orbit yet. And it's going to eventually, of course, crash because it runs out of energy. All right, and you could do this experiment 1,000 times. It's never going to achieve a stable orbit. And we know, of course, the moon is actually escaping Earth's orbit, not falling into Earth's orbit. So how is that? How is this a description of anything? To up the ante, he's going to actually add another mass here to the fabric of space-time, and then he's going to roll the balls around. He's going to let his students interact. This is good teaching. He's going to let them interact with it, and not a single one of these students ever achieve orbit around the masses. And guess what? These objects also never spontaneously combine themselves together because of the bending of space-time. He's just going to release a whole bunch, and wow, worlds in collision. But not a single one of them is achieving orbit. It's absolute failure. Observationally, I would say, therefore, general relativity is a complete and utter observational failure. I think we can hit next. Hilarious. All right, so whoops. So we have some circular reasoning. First of all, he's using Newtonian physics, that is the concept of weight, to demonstrate general relativity. But we know that general relativity is supposed to replace Newtonian relativity, and that MOND has not been confirmed. Newtonian gravity outside of dynamics and mechanics on Earth has not been confirmed to work in space, according to astronomers. So if that's true, why are we using weight and the idea of an orthogonal distance? And here's what you always see, this image on the right. They'll always use the fabric thing, and it's an arbitrary fabric. So the question is, what should happen if you turn this fabric in arbitrary directions? You know, you should have to do it in 360 degrees by 360 degrees. And if you do that, you of course create a kind of a weird sphere around the object, assuming that the object doesn't actually touch the space-time fabric, in which case nothing at all would ever roll towards that center, because the sphere would be bent in all directions at all time. There would be no instigatory force no impetus for anything to fall towards that center, because the sphere would be negatory on all directions. And you notice that the object in the diagram is always sunken below the horizon, or at least deep enough in that it sort of becomes arbitrary. So if this one is displaced at like z equals -2, and then I flip it over, is it at z plus 2? Well, why isn't the star, when we look at the sun, why isn't it vibrating between a low z position and an upward z position? And that's only two directions chosen here. And he's defying observation. He's somehow creating some kind of stable orbit. Forget the energy, just the mechanics of it don't work out. Mathematically, they don't work out either. You'll always see these computer diagrams where marbles are made to roll on the edge of that fabric bending. And yet, in reality, if you were to put a marble on the edge of the fabric, it will, of course, fall directly into the center. It will, for no reason, will it keep rolling in another direction. That's Newtonian concepts of inertia. So it is a mind game that they're playing. And the angle, of course, here is completely arbitrary. So hit next. All right, you guys already understand this. AM87 is not a black hole. It's not a photograph. It's composite computer graphic image composed of 1/1000th% of the EMF's signals selectively received. So this is via Robitaille. The vast majority, what is that? 999 out of 1,000% of all the information received is discarded, in which case you are not describing the image at all. You are describing some arbitrarily selected image. But let's say it's stitched together in a way that is somehow correct. Even though they are looking for a specific thing, we still don't see an accretion disk. And look at the timestamps here.
You're verifying your model.
That's right. You're verifying your model in order to get a result that's predetermined. And here we see that the disk does not rotate over any of these days, but it should rotate because these black holes are described to be rotating at many times per second, sometimes hundreds to thousands of times, other times just every couple minutes. But certainly over several days, this disk, this accretion disk, should rotate. If anything, it appears to go one direction, then come back. And it just isn't rotating because, of course, they're seeing higher electron mobility in one area, a greater charge density and a greater arc mode in the plasma on the quote southern end here, and less on the northern end. They're definitely seeing all sorts of other things too. They're getting X-rays, they're getting radio waves, they're getting plasma. They say that SGRA sometimes burps gas, and if it burps it, you got to wonder what speed does it have to come out to go faster than the speed of light. So 1 second, nothing can go greater than the speed of light. But if it's going to escape the center of SGRA, then why in the world how would it do that without it going faster than the speed of light? Go ahead, Rick.
Yeah, why did they image a black hole so bloody far away when there are so many black holes way closer that they could have imaged? Because this one matches the parameters that they needed to see.
That's
I believe
exactly right.
fully.
They needed it to be a certain size to fit their modeling and their desire to create a certain satellite array and to run all the algorithms. But the other thing is they claimed that it was nearly facing us, and we're going to see in a minute that it's totally not. So here we have what should be an accretion disk, and it absolutely refuses to be an accretion disk. I think everybody on the call can see a volume to that. Yes, it's a torus. It's got volume. It has depth, and you can see the depth because of the faded aspect and the changing of the shape. Okay, next. All right, so lensing. Here's a great example of a classic lens. The problem is, if you have lensing around this object, why don't we see lensing around any of these other objects? Now, they can claim that it has to do with the amount of mass, but the mass around that galaxy on the right is going to far exceed the amount of mass contained in any black hole, period.
We're looking down the length of a Birkeland current there.
That's exactly correct. So why would anyone think that gravity should interact with electromagnetic fields when literally on Earth we don't see this, right? We don't see that if you turn on a laser that the gravity of the Earth is affecting it. Now the Earth's magnetic field can affect that laser, but it's not going to on account of the weakness of it. But if gravity altered light, then we would see this immediately around the sun. The gravity's connection to the sun always follows the center of the star and Earth and does not lag by the 8-minute gap. So there is a direct connection, and that connection is, of course, easily described using vectors, but it is not easily described using spacetime. Eclipses, of course, are light from the photosphere coming to us around a magnetic body, that is the moon. It's slightly magnetic. And interacting with our own plasmasphere. It's 100% an optical plasma observation. It has nothing at all to do with gravity. And in none of the equations is gravity present. Lensing is gravitational. Gravity is spread out by the waves. So why not is it not seen everywhere? Only in the linear direction around the massive charged object. But this is just not what we see when we look directly at the sun. Next. So here's the video. I think many of you have seen this Markland convection video. Hopefully the sound will work on this one. If not, we can still get the effect. All right, so you can read here, filaments carrying the current in the same direction. They start wrapping around each other. They exhibit long-range traction, short-range repulsion. Together, these two forces cause the filaments to twist around each other. This is the Birkeland behavior. This geometric combination of electric magnetic forces produces a radial force nearby ions, electrons inward towards the center of the filament. So they act as ion sumps, clearing the material. Once the elements approach the filaments, the process of Markland convection radially sorts them into concentric rotating cylinders. Helium forms the diffuse outer layer, followed by hydrogen layer, the oxygen, nitrogen, iron, silicon, magnesium, etc. And this is what we do see in some of the larger filaments in the universe. If the charge density increases, the geometry in the state can transition towards a Z or Bennett pinch. They're very powerful ion scavengers. There you go. And usually the video goes longer and then it forms a ball. And that's possibly one way that stars could work. We don't know. That's okay. We'll just go next.
Stars are just plasmoids.
Yeah, they're plasmoids, exactly. But wait, there's more. So on the right there's the M87. That doesn't look like it's coming towards us at all. So I'm not sure exactly how they were deciding that this is facing directly at us. Maybe it's more facing the jet coming out of it. The so-called jet is more facing at us. The left there is the Crab Nebula. showing its electric motor behavior. And you have the rotor and the stator behavior, and of course inside the rotating pulsar. Might even be a magnetar. I haven't looked into the Crab Nebula center to see if it's a magnetar, but it's almost certainly not a neutron star. It is rotating at a high rate of speed, and it conforms to really every descriptive model of electric motors, AC electric motors, going all the way back over 100 years. Next.
Well, I'd like to add.
Go ahead. Absolutely.
These pulsars that are spinning at dentist speed drill speeds are the standard model. Don Scott's model of a pulsar is an electrical phenomena.
That's right.
Where it pulses at 30,000 times a second, but it's an electric phenomenon, and it's not spinning that fast.
Well, you can have both. I mean, we can see that there is some radial behavior, but the spin doesn't need to be that level. But remember, the higher the current, the more the velocity that we see in the universe. So the Earth is going around the sun a certain speed, and then the sun is going even faster around the solar system, and the solar system's moving even faster through the galaxy, and the galaxy is moving even faster through the supercluster, right? So it continuously increases. And so the current here that is going through is going to be directly related to the overall circuit behavior. And the sooner they get that, then the sooner we can, of course, harness that kind of power. Next. So here we see on the left, we have Jupiter, and mysteriously, surprise, surprise, has extra poles. These are going to be Rick's favorite thing, the Birkeland currents that are connecting it to its satellite bodies. But we do have to talk about what could be the first Birkeland current that we need to get verified. Of course, everybody knows about my Jovian octagon obsession there on the left, but you notice the southern pole, when we first arrived to Jupiter, had a pentagram, and then suddenly formed a new, quote, storm the size of the United States, and then formed a hexagon since we have been there in the last 3 years, which tells me that it is quite possible that Jupiter is, and this is the southern pole, could be running a new current from the southern pole of Jupiter to the southern pole of Saturn once again. So everybody wants to talk about the change into the age of Aquarius and all the things. Why is Earth's magnetosphere changing? Well, it's quite possible because the original brothers who were the children of the split egg, the cosmic egg that was the original Kronos or Anu, has split, and they are still connected to each other. And I would say that this is a variable relationship because at times the pentagram has been a sacred star, and at times the Star David, the six-pointed one, in China as well, not only among the Hebrews and the Europeans.
Can I add something again?
Of course.
Perfect. The encounter of Jupiter with Saturn, you mentioned that the Earth may have flown over top the northern pole of Saturn. What if that encounter moved their magnetic fields and pulled their storms around to the equatorial regions, let's say, so that we could directly see them?
Well, I guess it's possible, but how to keep them in the same alignment? Because remember, the entire point of the 8 on 8 is that the statistical likelihood that they were there. We know that those earthworks have been there for thousands of years. The statistical likelihood of the coincidence of those eliminates the idea that the Indians didn't have any math or trigonometry. Of course, they could have been Phoenicians or something. And B, that there's no coincidence between them. Engineering wise, the coincidence is zero.
Right, but if the poles just moved from the North Pole to a different position on the sphere and didn't change their structure, then they could still see that without us flying over the top. I kind of have a problem with us going over the top of Jupiter is what I'm trying to say.
Oh, well, of course, that's perfectly valid. There's plenty of evidence that the North Pole did face south at one time, and there's certainly lots of mechanical evidence now, and there's lots of cultural evidences. But we'll have to discuss that in a different time, because this is not an EPMC presentation, but certainly refer to my paper, and you can see the calculations and the overlays. And
you mentioned I like Birkeland currents, so I had to add something there.
That's true. It seems hard to me to believe that they would end up in exactly that same arrangement of the asymmetric octagon, but I can't rule it out, because I just, it's physically impossible.
Well, if you think about it, like the sun is supplying Jupiter with a Birkeland current, and it's flowing through its magnetic field. Now, if its magnetic field changes position, has to move because there's another gas giant right beside it, then
we're nearly done, Rick. We'll get into the we'll do some Q&A here real soon. Okay, hit next. We're really close to being done. Okay, this is Enceladus and Saturn, and that's the actual measurements that they did. Up in the upper right there is one of the early models of Jupiter and Io. So electric currents in space are not controversial. I don't care what Professor Dave professes to know. They are completely normal and standard material now. And if anything, we are at the very beginning of unwrapping the layers. We actually now have a measurement of the granular voltage for each solar wind. I don't have it in front of me. I have to look in one of my papers, but or I can look it up because somebody else's paper. There is a voltage associated with every single one of the average solar particles that are coming through the solar wind. And it's a non-trivial amount when you consider the overall volume of particles, even across a cross-section of the Earth, or say the Van Allen belts, or even the size of the Aurora Borealis going around, and the current that's coming into if you were to calculate the flux of that, it is not a trivial volume of current. You could do it today. You could actually measure the solar wind. You could create an equation based on a certain geometry at the North Pole, and you could tie it into their system where you would get exact solar wind speed and particle density today, and then you could calculate that out with Maxwell's equations, and then double that up because the South Pole is getting it as well, and have the electric currents at a minimum level going into the Earth every day. And that's probably how they get the 3 times 10 to the 9 amps number. I'd have to look into it to find out. Next. I love this graph. As soon as I saw it, well before the new models came out, as soon as I saw it, I thought this was hilarious. So you have gravity, you have material flowing, of course, is moving, but they're showing field lines in a curved and magnetic. You have to be pretty schnookered, I would say, to not see the coincidence of the flowing field lines and material here, and all this material is charged, and yet that's exactly how they interpreted it for the longest time, and maybe even still there's going to be a number of people, but when they see that bipolar structure, it's going to be pretty hard for them to continue. So the matter's flowing along charged filaments showing polar behavior. I discussed this in a 2018 paper, and we just need the new models to show more detail, and we will see the electric currents on a supragalactic scale. And we could even now coin the new would be supracluster, because we're now talking about the movement of electricity between clusters like Virgo and the Great Attractor and Laniakea. We're going to actually have currents that are unimaginable in terms of power levels. that one could almost make a religion around that, just around the amount of power. Even the Chinese could not imagine when they based the religion of Shangdi, just as the Hebrews did around the thunderbolt. They could not have imagined that amount of power was actually quite trivial. The the Peratt thunderbolt measurement is on the order of only, like a hydrogen bomb in terms of energy. That is not very powerful ultimately at the scales that we're talking about. And that's just, possibly just magnetospheric rubbing or a CME generation. Next. So there's all sorts of reasons why the sun can't be gravity fusion. We only need two. And these are the ones I'd love people to harp on. First, the acceleration of the solar wind defies standard gravity plus explosion mechanics. When something explodes, it's fastest at the place where the gas
epicenter
expanding. You're right, but it's going to actually reach its greatest velocity at the end of the muzzle. So at the edge of where the gas is expanding, once it leaves that expansion, there's nothing to apply that force anymore. So it would be fairly close to the sun. And then that CME, when it reaches its crescendo and bursts out, that should stop accelerating, but it actually speeds up. And there have been times when the solar wind has reached 50% the speed of light. There's also been times when it shut off for a couple of days. So there are diode behaviors, but the main point is that only in the presence of a field can the particles accelerate, and they've measured it, and it's not magnetics. The magnetic field cannot account for, and they've admitted that in the standard model, they've admitted that the magnetic field cannot account for that ejection, and that is the coup d'etat. You can talk about the temperatures in the sunspots, and you can talk about tufting, but the coup d'etat is that the field surrounding the sun is electric. There is no other explanation. The sun is electric because there's an electric field surrounding the electric sun. You can't say that there's an electric field because it's surrounding the gravitic sun. If I put an apple on a table, the gravity of that apple will never produce an electric field. Not once in a billion, trillion, zillion years. It will never happen, right? So to have an electric
energy flowing through it to create
that's
that
exactly
field.
Correct. To create that electric field, there has to be charge, and that charge is moving. And so there is also magnetism at play. And that object is consuming energy, and that energy has to be coming from somewhere. It cannot perform work on itself. So therefore, it cannot be a gravity sun, period. Next. And then the second is that we now know for sure that there are magnetic fields connecting the sun to the earth. Now, magnetism, as I mentioned, does not flow, and it doesn't technically really reconnect and disconnect, right? These are descriptions of densities of the magnetism. You can create your own experiment where you, this is in the Hawkins electrical field guides, where you suspend a magnetized piece of metal from a string, and above the permanent magnet, you can actually flow. You can see the lines of the magnetic field, but as you lift and drop, it doesn't jump from one field line to the next, right? Because the field is in place. It's in its place. The magnetic fields that we see around the earth are roiling, which means that they're changing. The only way that they would be changing is if the conditions are changing. Of course, the earth is rotating. And so there's a certain amount of induction and magnetic, the magnet spinning around, inducing electric current. But the space between the earth and the sun is roiling because there's electric fields and electric currents changing the magnetic fields. And this is again, non-controversial information measured by NASA's own satellites. Beautiful work, beautiful work. Next. By the way, the magnet's, of course, not responsible for the acceleration. So the Torella says, look at this. Plasma can recreate the shapes of the galaxies and recreate their rotation rates almost perfectly. I would argue it's not perfect only because the planetary terrella is in the presence of the Earth's magnetic field. So if they took the planetary terrella to the middle of voided space, so they have to go outside of the sun's heliopause and then somehow find some kind of dead space, I would say that the plasma would behave exactly in the way that is prescribed to describe the rotation rate, and that you would never ever need any form of dark matter to describe that motion. Certainly, there are confirmed galaxies without any dark matter. So if you have galaxies without any dark matter, then you basically have no reason to have dark matter in the first place, because there's supposedly the dark matter is what's holding those galaxies together and keeping their rotations right. Of course, they're doing all sorts of mental gymnastics to try and keep that model alive. Next. So solar fusion is electrical phenomena. There's transmutation caused by atomic rearrangement by the currents. The atoms only need simple geometries. Everybody can refer to the structured atomic model. In Big Bang, though, you need dark matter to hold everything together. You need dark energy to keep it expanding at the rate that you need it, and it's expanding at different rates in different places. So then the dark energy has to be concentrated. You have to make up all sorts of things that you just don't need it. Plasma on Earth and in the magnetic field is almost perfectly replicating the shape and spin. Refer to these Sapphire videos and papers, and which there was some fusion in their first paper, but they had not verified it yet. So they proposed a lot of different potential equations, and they still need to quote verify all of it, but it does look like they're producing fusion. Remember, this is only the anode portion of the sun model. They did in the original experiment, they had the cathode too, but they focused on the anode. So they just need to add that back in, and then they need to add the magnetism. Next. Now remember, for lensing, fusion, special relativity, black holes, none of them can be observed, measured, explained, modeled on a computer, or verified without the use of electric and magnetic forces, plasma, and other behaviors seen up and only explained on Earth in plasma laboratories. Cosmologists try to use math as science, but Feynman has something else to say about that. We're not getting sound, so we'll let everybody go and watch that on their own. And I think the final slide. And for more information, links on the left. And look at all the stuff that we didn't even have to get to in the uncovered topics to totally and utterly wreck the gravity cosmology. So it's not that I don't believe in gravity. That's one of the attacks that sometimes people use against the electric universe, is that gravity is a placeholder for a future well-known science. It is obviously, it's a self-obvious phenomena, and it's one of many plasma electromagnetic force phenomena. The actual mechanism of it is not yet quite understood. But if you know, obviously, if a person jumps off the roof, they're never going to get repelled and float up. They're going to fall down to the ground. But that is a excellent description of some kind of attractive behavior. And now the question is, how does the atomics lead to that? That's going to take better men than me in order to totally prove it. But if you had Newton here today, he would assuredly be in the camp of the plasma electromagnetic cosmologists. He would not be in the camp of Einstein because Newton himself was always interested in the newest model of how to discover what phenomena was behaving like. And once he understood that his favorite topic, which was optics, if it wasn't mysticism, optics is an electromagnetic phenomena, then everything, because everything entering your eye and that you're touching is an electromagnetic relationship, engaging in these electromagnetic fields, and getting these fields defined as the relationship. There's going to be a mathematical description of this, but the relationship between objects and between described entities is what a field is. And there's no thusness to that field. You don't need to have an ether. We think that there's an ether, but you don't need to have the ether in order to describe the relationship, because there's a connection. So you can view the light as connecting between the source and the receiver, which might be your eyeball, it might be a detector. That connection between the two becomes energized, and that energization is the exchange of that light. And the light that is being shown or detected or seen is the revelation of the detection or of the energization of that electric circuit. And that's all that you need there. You don't need any kind of special fluid or anything. You don't need an ether called space-time, and you don't need a quantum foam. Now, it's possible that those exist because that doesn't eliminate the discussion of where's the source of the freaking energy come from. That's the discussion that's most relevant, because the general relativists don't have an answer for that. The quantum people know that the answer is we don't have the answer. That's what they know. That's the extent of that, and they call it void energy and et cetera. But sticking to just the facts, as far as looking for a unified field, we found the unified field. We haven't unified it in our brains and in our hearts and our minds, but we found the actual unified field. Now, how much of that field can we discover before we use it to create weapons of the gods and destroy ourselves? Because that's all getting into the extended plasma electromagnetic cosmology and some Velikovsky psychology stuff. So that's the end of that. I want to open it up, let people talk about topics. I had promised for Connor if he wanted to talk about light, and then it sounds like Rick wants to talk about Birkeland currents. I know it's just I think Rick, it's your favorite topic. Connor, did you have anything you wanted to ask, or did you want to counter, or how do you want to go about the discussion of light?
Thanks, Ramon. Can everybody hear me?
Yes.
Can you hear me?
Yes.
Yes, sir.
Okay. My question is just, and really it just ties into some of the stuff I've been musing about, and that is, where does the photoelectric effect come from then? So why is it, from a plasma electromagnetic perspective, why would it be the case that voltage, I'm not even going to use, because we were talking about atomism and stuff like that too, I'm not even going to use the term electron, but why is it that when charge or when voltage is somehow like slotting itself into this new relationship to whatever the mass is that it's energizing or something, you think of electrons and protons, but why is it that when it changes its position relative to this thing, that light would be produced?
Well, again, the idea that you are producing light is probably not the most accurate description, because in that way, that would be like saying that my genes, because they're radiating blue, my genes should eventually run out of energy because they would be producing the light that's coming off of them. And nobody talks about this, but the fact is that these, so long as they exist in their current state, will keep radiating that color at a consistent level, from what we can tell, forever. We don't have an upper end for how long an object, whether it's a white object or a black object or any color object, will keep radiating light, just being in its natural state. It's not really consuming, from what we can tell, anything. If it were, we'd probably be in trouble. It seems more that it's in its natural state of actually releasing that. Now, the model of a quantum effect and talking about vibration and the release of a photon, those are really useful descriptions, and they certainly work in order to create lasers and other industrial techniques and things that we know we get results if we use that description of that model. However, it doesn't erase the single issue surrounding light. So we're going to pull an Einstein. We're going to do a thought experiment. If you put a light source in the center of let's say a perfectly cubed room, or it could even be in your mind a perfectly spherical room if you like, but it's easier for me to picture a cubed, and it's a perfectly reflective surface. so that you can get a great measurement. There's nowhere on the paint that it's absorbing some of the light so that it creates any splotches. So you have an even layer all the way around. Now, when you have the walls close to that light source, you expect that it has a uniform amount of light across it, right? You don't expect that there's a shadow that would appear here or there, unless, of course, there's an object in the way that's blocking the electrical connection from the source to surface. Now, if I were to expand the room to a very arbitrarily large size and contract the light source to an arbitrarily small dimension, but it still put out enough light, enough energy. Like, let's say it had the equivalent energy of the sun. Would we see modeling from collections of density of the light on the wall? And would that modeling move around? There is almost no likelihood that that's what we would see. The light continuously expands and fills that space. And if light really was a particle moving in a vector direction, even accounting for its vibrational, the distance that's rising and falling mysteriously according to the standard model, then at some large distance, the angle between the vectors would exceed the actual output of photons from the number of atoms in the light source. And yet, that is not what we see when we actually look at light. When we turn on a source, without barrier, it lights the area around it in that uniform manner, which is obviously of great benefit to us. So we can put a filament in the center of a light bulb and expect equal amount of light in this part of the room and that part of the room, given the same distance from the source. And we take that for granted, but that's an excellent example of how when we particleize and materialize the concept of light, we start to lose the description of the field effect, the smoothness of how it can actually connect with all those surfaces. It is probably a better thing to say that each of the atoms on the surface of this expanding room has a connection and relationship with each of the atoms, and even if they're real, the electrons in the source, and that each one of them receives their own individual light connection. Now, it doesn't mean that we can't have reflection, because that reflection and the description of things bouncing around is quite useful in terms of angles and putting mirrors. Obviously, magicians rely on that quite a bit. But what's really happening there is just the way that the connection from light to source is just being intermediated by a reflective surface. It's passing information along. It's not actually bouncing anything at all. And they think that it's bouncing, but there is a electromagnetic effect called the Bifid-Brown effect, which explains why the Voyager craft drifts. You don't need light imparting momentum onto a satellite. When it deposits charge onto the satellite over time, the charge, of course, accumulates to a level where it saturates. And then the charges spread out, and you end up with more positives on one side, more negatives on another, and it's just enough to be non-trivial. And when it's non-trivial, then in the presence of the solar field, of the solar wind, so called, then the Voyager satellites will drift according to the Bifid-Brown effect. This was discovered in the 1920s. It is standard science as well. It is. He was never given a Nobel Prize, but there it is. I mean, it's incredibly important science that no one's talking about, not in the electric universe. No one, except for, I guess, some of the electrokinetics people, especially ones interested in whether or not the stealth bomber and UFO government activity uses electrokinetic effects. But they constantly cite this idea that the photons, which have no mass, are, so if they have no mass, then their momentum is zero, and they're imparting momentum. So they have invented something that's violating thermodynamics once again. So if energy is being imparted from the system into the Voyager satellite, two things. Number one, is the satellite heating up over time? And number two, is that region of space losing energy? And where's the proof for any of that? There's no proof for that. So we have a standard electrical effect that is measured on Earth, and that is perfectly describing the behavior. Whereas we have also seen in lab demonstrations where they slow down light, and when they slow down the light, so therefore I guess it's not constant anymore, but if then they slow down the light, then you can see that the light going through the bottle instantly reflects off of the desk below. You do not see particles leave the bottle and travel in slow motion to bounce off of the table and then bounce towards the camera. You don't see that. You do see the light reflecting off the table. So it's not only the light going through the bottle, you see the light reflecting off of all the surfaces. And when it does so, it is only trailing in that, the angle, the way that the light is reflecting. Otherwise, it's not trailing at all. There's light ahead, there's light behind, and it's reflecting off instantly. When it goes through a certain surface and the geometry changes it, the refraction instantly changes that connection, and there is no delay from the inside of the bottle down to the surface back to the camera. So they debunk the photon right there on camera, and again, no one's noticed it. It's kind of amazing to me.
Raymond?
Hey, Ramon.
Yeah. Oh, sorry. I have a simple theory of light. If you'd like to
go ahead.
Feel
free, guys.
Sorry.
Wait. I need to go. So if I leave, everything will still be recorded, right?
The recording is going because of Buddy. Yeah.
Buddy's doing it. I'm gonna
go ahead.
Thank you, Ramon. I'm gonna leave an extra question that I'd like to get your opinion on in the chat. Thanks for everything, and talk to y'all soon.
Welcome. See you later, Connor.
Okay, take care. My theory of light is this.
Hey, everybody can unmute, by the way. It's fine.
Okay. My theory of light is this, that we live in photonic soup. They're everywhere. You turn off the light, they're still there. They move in like 180 degree you know what a Newton's cradle is, right?
Uh-huh.
They move in that manner in like 180 degree arc. So a light source in the center will push towards a certain direction, a central direction, but it's moving these photons as it moves through.
Connor, I just want to let you know we could still see your monitor. You need to disconnect from Skype. Hope we heard that. There you go. See, buddy. My response to that, Rick, is that you're still basing it on a material paradigm, whereas what I'm advocating with plasma electromagnetic cosmology is that you base everything on a connection paradigm, an electrical circuit paradigm. And in an electrical circuit,
right. Well, the connection is that these particles, or these so-called non-particles, are touching each other constantly. They're connected basically to, and a perturbation of one of these particles sends a perturbation 180 degrees and a stronger one in the central axis.
Right.
You know what I mean? That's what
I would just challenge, and I would say, why do we need the particle at all? It's a good model that
the photon isn't actually a particle.
Right.
There in the 1930s, two scientists theorized that there that 2 photons make 1 electron. I think that an electron, if you impart enough energy to it, and its vibratory rate, everything has a vibratory rate. If we can increase the vibratory rate of an electron, it will split into 2 photons and not have any mass.
Well, again, if that gets proven in lab, then I think that we're cooking with fire. Of course,
we do have the technology now to test that, but nobody's building the experiment.
Well, yeah, that's exactly the issue there. There's a lot of excellent theories out there. I heard one earlier that the Titanic the seam may have opened up because of the rivets. As most people know, the Titanic has these metal plates that were layered, and that was supposed to make it extra strong. So the theory behind this, and there were groups of people who probably got in just as heated a debate as anybody in the electric versus standard model and inside of the electric universe community, who were adamant that these rivets would have been the failure. Maybe they were weak material, or it was the change. There was a change made to the Titanic on account of the sinking of another ship, or a near sinking of another ship.
It's been proven that it was the steel plates that were brittle. They were too brittle. They didn't soften them enough, and they broke.
The point is, they then took these into the lab and applied pressure, and the rivets, the first rivet breaks, and the rest of the rivets didn't. Not only did they not break, they formed a tighter wedge that made the plates more watertight. So the rivets were not responsible in the least for the failure of the Titanic, as you pointed out.
It was the failure of the plates themselves that broke.
But I'm not focusing on what actually caused it. My point is that we have a theory, and the theory sounds perfectly rational, but only the testing in the real world generates the actual answers. It's sort of like we can talk about the electrical scarring on Mars and on the moon. However, you have to generate those in lab, like Yelverton and the others have, and then you have to find actual examples, like I have, where you go out and Buddy, I'm not sorry, not Buddy, but Robert, talking about this the salt diaper in Utah, and you have to actually show those results. And what I found in the Garden of the Gods in Illinois was the smoking gun. Aside from the Thunderbolt craters that I found, the Paradian Thunderbolt crater, the smoking gun of that stone was shaped on Earth by electrical phenomena, because the process of the lysogang bands, the way that they describe them standardly, cannot be replicated in this environment. All the other lysogang bands in the entire park form to their theory, but not the ones that they actually had.
Yeah, the uniformitarianism.
I can't tell who that is. Who said that? Okay. Good night, Adam. I hope Jen listened and enjoyed as well. And I'll talk to you soon. Cool. Great. Now I know that that Aaron and Buddy have got ideas, and they're very quiet and super respectful.
Sound off, fellas. I mean,
yeah, sound off. Seriously.
So screw you, laddie. That was a meme, by the way.
What was it?
A meme.
Oh, a meme. I thought you said it was.
It was a meme. A vocal meme.
No. I thought that another Jenny was going to make it tonight, but I guess not. But I think it went pretty well. There are so many topics. The solar fusion thing, I mean, it just goes on and on. The descriptions of why solar fusion does not work. From gravity, it's endless. The point of this, presentation is to make it short and sweet. Certainly for people who are interested in alt stream I think it's important to capture people who are interested in alt stream, who have been, unfortunately, they've patched together a cosmology for themselves because they've escaped the
Based on
standard cosmology.
mysticism or some other thing.
Well, I mean, there's a place for mysticism. We were having a spirited discussion elsewhere today about magic. But again, ultimately, for me, that's going to come down to some form of, ether and electricity coming together.
Well, I've said it before that spirituality and science will eventually merge. They will find a connection between the two that is undeniable. And
well, I mean, I think that we have the story. There's some people out there, even in our community, that say they hate the Thunderbolts talking about myth and all that. And I think it's really actually important. If I found anything out, it's that it's more important than even Dave and Walt Thornhill have known.
He's wrong. Everything connects with everything else. Everything.
That's exactly correct. I mean, the description of what's happening in our world, the transhumanism, everything is related to. I think if you want to get psychological about it and not just
Tesla and his feelings and his thoughts were all connected. He was highly connected to the ethereal plane, if you want to call it that, or the Christ consciousness, or the Akashic record, whatever you want to call it. He was highly connected to that, and he understood. And
are you talking
Tesla,
yeah.
Nikola
Tesla.
I
completely agree. But I was going to say that I think that in the absence of that connection, you now have a situation where people are going to force that connection, and getting away from the conspiracies about 5G and the conspiracies about.
Well, that goes to Tesla
everything.
saying when we start to investigate the subtle energies, that's what we're starting to do now with Sapphire.
Do you think that
the heating, the heating at low power is a subtle energy that we're going to start exploring?
Do you think that people are magnetized, for lack of a better word, instead of saying gravitate, towards microchipping themselves because they want to have that connection on a subconscious level?
Well, that's possible, but I think these chips are just basically, like move your hand past the door and the door will open for you, or you can pay, through your internet account with your chip number, and that's all that is going to be.
Aaron, use your words. Okay, he says magic religion is a way to find peace in the fear of the unknown. Dude, you're getting too deep for us now.
Yeah, religion is anyway. I'm not sure about magic. I think magic was more recently is just entertainment. But there are some things that are magical.
Well, there's quantum effects, and the quantum effects are electrical effects. That's another thing people got to know. When we say quantum, we're now opening the PEM toolbox and reaching into the quantum electrodynamic drawer to describe things that are happening that have actual value. I mean, I can't even tell you. I literally, and I think it was Aaron that I was talking to, I described a patient. It might have been my brother. I described a patient and her interaction, her behavior. She was a feng shui client, and I was helping her business, but 3 of her businesses were under the water. I kid you not, within the day, I hadn't heard from her since before Christmas because she didn't even respond to my Happy New Year's text. The next day or the day after that, I get a text, an email, and I got to see you, and I got to come in, and she becomes one of the first patients to return during this lockdown. So the connection, there was some type of electrical and spiritual mental connection there. There's quantum entanglement that is happening. And that entanglement has to be exchanged through electric forces. It has to be exchanged through electric forces. And the idea that we can get rid of electric forces by just talking about magnetism and dielectricity, I think Ken Wheeler is full of crap. Because I do not think that you can just eliminate them. I'm not saying that they're not separate, that they're all separate, that the dielectricity and magnetism don't combine to create I'm not as
Oh,
smart
it's
as
a
Heaviside,
dance.
so
It's a
maybe so.
dance of all of these energies
All of them.
that makes up our universe. All of the subtle energies, all of the dark mode energies, all of the glow mode energies, all of the arc mode energies, the scalar wave energies, the energies that we haven't even found yet.
Right, exactly.
All of it is a dance. And I believe 100% that your seat that you're sitting in, your table that you're looking at, your computer sitting on, or your phone is all energy organized into matter. Down at the quantum level, it's all described in cymatic patterns. It's all energy patterns organizing matter into photons and electrons and all of these
Different packages.
quasi-particles and semi-particles and particles and accumulations of particles. It's all
Right.
these dances of energies working its magic. And Buddy would agree with me on a fractal scale, working
Right.
from
And
down.
unfortunately, Connor had to go. Connor wanted to talk about the fractals. And I would again argue that the fractal and nonlinear aspect is one of the undiscovered principles in the plasma electromagnetism. Of course, the math is a descriptor. Math is the model.
Well,
whether
no, we know that plasma is scalable, so that's not
Yes.
really. We've already discovered that it's fractal in its
Yeah, of
very
course,
nature.
I didn't cover that at all in the presentation because that's now a whole new
Well, it's still the question
realm.
answer, right? So
It's right. It's there. I mean, the issue, and ultimately getting to, unfortunately, like I say, he had to go, but the answer is that there are actually fractal connections inside between the particles. It's not just between the atoms that
and
are
fractals
interacting
are
and
super
sending light.
important part of the process.
Well, again, what I'm trying to say though is that there is actually light interactions inside of the atom that we can't measure at all, of course. And these light interactions inside will be reflective again of these miniature electric circuits. And these, when they pull back and describe them, the only thing they can do is say, well, then there's a mass, and that mass is measured in electron volts. Why is it measured in electron volts? Because it's actually an electric circuit. And we don't understand the electric circuit because we're used to looking at everything in wires. But
Well, see,
we still think that
photons
most people think that the copper wire is thick because if it's thick, then more can flow down it. But actually, it's thick in order to increase the surface area for the electricity to flow on the surface. It's a waste of copper, if you ask me. But anyways,
Interesting.
long time. I think it'd be pretty hard to open up some 12 gauge wire and like core out the copper to get it back. If we get cheap enough, and if we don't start mining in the deeper parts of the crust of the earth with robots and AI, we might get desperate about the copper situation.
Nah, we're not going to need to, man. We'll just create it in sapphire.
Yeah. Hey, listen though, is the government going to let that turn into, get out there that far? I mean,
I hope
who's their most likely purchaser? Unless Montgomery Childs and all them, if they refuse to sell to the government, that's one thing. That'd be great. But I would say that their number one investor chance will be, if it isn't already stolen, because that's the thing, is the U.S. government does steal a lot of stuff.
Well, they're running a sapphire-like experiment right now, or they're building it in MIT.
Yeah.
So,
and I wouldn't be surprised if China steals the idea. I wonder what their cybersecurity protocols are.
But don't forget, there are patents. So the
China doesn't care about no patents, man.
Well, I know, but that doesn't mean anything. The thing is that
they're going to generate. That's the good.
Patented the process, and they've patented the reactions, and they've patented what's going on in the reactions, and they're patenting the process of creating elements. I mean, that's what they're doing here. So
I have a hard
hopefully,
time believing that they have the kind of patents though that can stand up in court, because those patents are $20,000 and $30,000 a piece. You know, so I just have a hard time because I don't think that they have the funds. That's, you know, my personal opinion, but
yeah, we'll see.
maybe.
We'll
I
have
mean,
to
I
see.
always hold out hope, but I do
Maybe
believe
Canadian patents are cheaper and they
maybe
still hold
so.
up maybe they hold up in an international court.
Well,
So
they won't hold. I tell you this: the Chinese government does not recognize any foreign governments as far as all that lawfare
oh
stuff.
yeah,
They're happy to come to America and Canada and sue, you know, our companies. But if you want to go back over there and sue, you can't do it. So
No.
it's not a linear. It's not a fair equation.
Well,
But
it's
my
not. It's not.
concern,
You're not suing any company. You're suing the People's Republic of China.
right?
itself.
And that's not gonna fly. My concern is that they will actually try that their goal isn't necessarily cheap energy, but that their goal is to generate the first Palladian Thunderbolt generator. That's my concern. Think about that. It's possible.
Well, Tesla was on the verge of a death ray, so
Yeah, he gave us enough, though. I mean, and look what the U.S. government did with his ideas. I mean, they did open up the atom. They did create the long range missile. They did create the AI and the robot and the cellular, and and they did all those
they
things
did
for his
create the
ideas.
anti-gravity device as well, and they created the ET story. I believe this firmly, that the ET story was developed in the 50s to hide the fact that T. Townsend Brown and Tesla had perfected an anti-gravity ship, but they couldn't control it well enough until the mid 80s or 90s, when computing power got small enough and strong enough to be able to control this thing so that it wouldn't cause problems for them.
It's quite possible. I wish I had direct proof. All I've got is my personal conjectures, and I love making my personal conjectures. But I wish I could say that I had any direct sampling of that. There's some really great YouTube experiments with people have shown it fairly conclusively that it can be done. Of course, scaling that up, it's sort of like I wish somebody would construct miniature 9/11 towers and just show that you can't deconstruct them with just airline fuel. But the problem is nobody wants to take the time to build the like miniature concrete with miniature insulation and recreate all the core columns and everything but imagine how epic that would be. A 20-foot scale, a pair of buildings with guy wires, and you move the planes in with little miniature planes with the rocket fuel, and you recreate, and it looks exactly like it does, and then it just doesn't collapse.
I'm a good RC flyer. I can fly that thing right into the
Well,
exact
either way.
spot.
But if you want to recreate, if you want to create the exact, if you want to have controls, you put it on a guy wire and you send it in at just the right speed, and you leave no room, and you will, and people will see the daggone thing will never collapse. But we live in an age of post fact, so people would still say, well, that's because it's small and it weighs too little. You're like, oh God, it's just an era that we have, and of course nobody's willing to actually build.
But I choose to stay away from the 9/11 thing. I mean, I have my own thoughts, but I try and stay away from talking about it.
Well, I stopped giving people, because if people don't want to know, if people don't know about, if they don't want to know by now, they just don't want to know, like period. If they don't know by now, they don't want to know.
Exactly. I mean, I've made my mind up. I just don't like talking about it so much.
Oh, well, you don't have to. My point is that we have the ability to recreate a lot of these experiments, and it just hasn't happened yet. Mm-hmm. So in an ideal world, go ahead, Aaron.
So a lot of the scale models and stuff like that, what they don't account for is they don't actually scale back the tensile strength of like the composites and things. So for instance, you wouldn't use actual steel I-beams. You would use something that would be the equivalent of the 1/10 scale in strength and flexibility and everything else. And I don't know that there's really comparable like composites and things like that that would be capable of doing it. But it leads to the same kind of argument. Like, for instance, a map is a 2D representation of a 3D surface, so how accurate are you actually going to be able to get with that? Same thing with those kinds of models. How accurate are we going to be able to get by doing small benchtop like laboratory tests?
Yeah, and like so I was thinking about that too with the insulation. How are you going to make insulation that the fibers match the scale and tensile strength of? I mean, it's
It
kind
would
of
be
difficult to do.
Yeah, it is very difficult to do, and that's basically why people don't do it. So unfortunately, when it comes back to the original subject, let's say you want to take one of these, square ring or triangular electrostatic lift devices that are, of course, tethered down by a wire that hooks to the power device. Let's say you even create the wireless power transfer. No one has yet set in the private sphere that I've seen and created something that would scale in terms of weight to show how much energy it would take to produce that same lift. And that's my problem with the theory. I'm personally, I think electrokinetics is probably the step in the right direction for understanding electrogravitics. But we don't have anybody that has gone beyond what's been done for the last 100 years. That's the only thing. And I love devices. I love all sorts of types of devices, especially shaped toroidal generators and people trying to create over unity devices.
Well, we know from T.
I like
Townsend
all
Brown.
those.
We know from T. Townsend Brown and his experiments that you apply a positive charge to an object, and it will lift off the ground and oppose gravity.
Yeah, no, I completely agree. Of course, the repulsion off the gravity doesn't prove the electrogravity, right? That unfortunately, scientifically, that's not how that works. But it's a step in the right direction. But we're not getting any more traction in that because, unfortunately, a huge amount of the community that gets invested in those things also gets invested in certain types of save the world projects, and those save the world projects seem to lack the ability to stand up to scrutiny. Sapphire is the one thing I've seen lately that actually kind of can stand up to scrutiny. Although there's a lot of scrutiny available for the Project Sapphire, it's still, I mean, it would, if they would take it through, they built it. If they would take it through the scrutiny, it could survive all that scrutiny, I think, rather simply. Even all of Eugene's points can all be answered point by point.
Well, you see, Eugene wants to be complex at the moment. We're just, you have to
be simple.
We're just taking baby steps here at the moment, and we're just starting to verify that our sun is electric with the Sapphire experiment. Now, at some point, and I'm telling you, I'm here to tell you right now, when he says that there's no magnetic field around the anode, that's bullshit.
Well, I know that he's saying
you put charge into that. Hang on. As soon as you put charge into that anode, it develops a magnetic field, guaranteed.
Right. He's just saying that there should be many
double layers are way stronger. Like Wallace Thornhill says, 1,000 trillion times stronger than gravity. So gravity is apparently stronger than magnetism. So it's the electrical force is what I'm getting at is way stronger, and even in Sapphire, the double layering is going to overpower any magnetic field close to the anode. So then it would have to be a huge experiment in order.
Yeah, he's just saying he wants to see some like a 100 T's in there and to prove But to recreate the dynamic environment of the sun's magnetic field, I think is basically impossible. But you could create some kind of rotating magnetic field, but I don't know that it would really change the results very much. But you don't know until you do it. That's the thing. You got to do it.
Yeah, but they did it in the 50s with the plasmoid experiment.
Yeah.
There's our sun right there. Poof.
Yeah.
Our sun is an external plasmoid, a Z-pinch, a plasmoid Z-pinched. That's all it is.
I think it's completely obvious. Obviously, you think it's completely obvious.
Well, you see, Eugene says our sun is a disconnected plasmoid that's bleeding off energy slowly. I disagree 100% with that.
Yeah, I don't know. I mean, until we measure, it's like one of those things that I would love to speculate, but what I would really love is for somebody to actually measure the damn situation. And the problem is,
he says there's no Birkeland current.
Right now, we can't get close enough to the sun.
Well, he says there's no Birkeland current connecting to the sun, and it's a plasmoid that's disconnected from all of the.
Anybody who says for sure either direction it's ridiculous, because we just haven't done it. It's just it's too difficult so far, and we're getting there. But right now we don't have any data, so how can anyone say either way? What we can do is, you look at overall the trends, and then you put everything together and you say what you think is going to happen. You make a hypothesis, you make a prediction, you get some, if people can get the balls like Velikovsky. Velikovsky had the balls. I mean, he made the predictions and they turned out most of the time true.
Yeah, well, like I say, we're just starting off. We got to take.
I completely agree with you.
And get up there.
He's being ridiculous about that whole thing, in my opinion. But he does have points. I mean, points is points. Whether or not they're ridiculous points is another matter. But when you have a point,
yeah, he has a few good points there. But I mean, it's a little difficult to do at the moment.
Of course it is. I mean, he's underestimating the amount of engineering that goes into that project.
Oh my God!
It's a lot of money and a lot of engineering, and it's not trivial. I mean, some very smart. The chemist, the video I watched earlier with the chemist. I mean, this is a smart dude. These aren't.
It was $10 million. It was $10 million plus to build that reactor.
Yeah, it's certainly a massive investment, and it's so important for mankind. I don't think that we have to have it in order to solve the energy problem on Earth, but I think that for us to go into space and to do what we want to do, we do have to master this aspect. Yeah. I don't know that it's going to happen right now on account of mankind losing its brains right now. I don't know how that's going to shake out. Right now, people are maybe not in their best. Yeah,
I'm not going to go into the Corona thing. Yeah, no, staying away.
But you know what I mean? It's like it could interfere, and that would be the most unfortunate thing, is if it interfered. So I hope it doesn't. And I hope that they get the funding that they seek. I gave Michael Claridge my idea of how they could raise money and get ahead of everything. Right. They haven't reached back out to me though. So, I guess they're probably going to try a traditional funding direction. But my idea, of course, is completely opposite. But that's okay,
Kickstarter.
No, but that's not a bad idea either. If somebody was really good, I don't run those. I'm not very good at those kinds of fundraising, like GoFundMe's and all that. But if somebody was really good at it, it always marvels me to see who. I think certainly there's enough people in the electrical community that would want, and they would be willing to pay that money. So
clean energy device, yeah.
It's not a bad idea. Maybe, do you know?
Go ahead, Aaron.
What's up?
Go ahead, Aaron.
Owns the company Launchboom, and they specialize in crowdfunding platforms and campaigns. It would be a possibility. I think if they wanted to seek that direction, it would definitely be possible.
Well, I mean, that's a good idea. I mean, get them in touch. I'm sure Michael Claridge, he would answer my email if I said, "Hey, I've got an investor," and they're an interesting bunch, though. I tell you, they're real cagey. Like if you ask them about newest results and stuff, they like never answers. They'll never answer. I'm always looking to get the latest scoop.
Well, to see the newest, the juicy results are the ones that are patentable, and they want to make sure that they got all that shit locked down before they release that information. So
yeah, I don't mind that. That's fine. I totally understand. It's just I always wish they would publish a little bit more, because
I know the silence is killing me too.
Yeah, I like to cite their work in my work. So
I hear you.
I think it helps with our
well, that's all I talk about.
Credibility.
That's all I talk about with this Professor Dave guy. I bring Sapphire up all the time. I say refute what Sapphire can do. Show me why the electric sun model isn't better than tokamak, which runs for 30 seconds at a time and tries to blow itself up. At least blow the plasma out one of the sidewalls.
It's funny about him. I think he and Ben deserve each other. I think they're both jealous. I think Dave is jealous of Sapphire, and I think that Ben was jealous of not getting debunked himself. I think that Dave has a good point that it's like Ben went looking for that trouble, but
I don't think Dave is jealous. I think he just believes the standard science community's theories 100%. He's drank the Kool-Aid and he's about to kick the bucket. You have the purple Kool-Aid, you know what I'm saying?
Where's the money coming from? Because obviously the governments and everyone else want to give money to something that supports the standard model or whatever, and so for him it's an unlimited funding source. I mean, where do you think they're actually spending billions and billions of dollars? It's not building a tokamak reactor, because like the machining and everything involved in doing something like that is, you can do that for a shoestring budget, but yet they can spend billions on it.
Right, but Sapphire is doing the science, right? And they're doing the science and being able to repeat so that they can show that the science is correct. And once they can do that for the governments and the investors, they'll be able to make people stand and listen, I think. Go ahead.
I was just saying, like, Sapphire is doing it practically on a shoestring budget. So, like, they're showing, like, yes, you can do it, you can get results. But yeah, they don't have the unlimited funding. I mean, if you were to compare lifestyles of the individual working on a Sapphire project and things like that versus the people working on the tokamak or the Stellar or even the CERN project, it's a completely different lifestyle.
Well, yeah, tokamak is high energy nuclear plasma. We're talking with Sapphire low energy nuclear plasma. So there's the difference right there. And these people are trying to get fission and fusion out of fusion reactions out of tokamak, when that's not necessary. We just want to make elements and kill the radioactivity and generate power.
Well, that's all got to be verified. Again, I believe it. I certainly believe it. I have no reason to disbelieve it, but I'd like to see a paper. I'd like to see the results put out.
Well, they did put the video results out with
what I mean,
showing the elements that they created.
I know.
9 of the 11 9 of the 11 that we see out in the cosmos.
I see it, but I would love for them to publish I'd love for them to publish even the lab results, like the verification from those labs, into a short paper with just basically bare bones that doesn't describe necessarily anything that is
you just want to beat somebody over the head with it, don't you?
Absolutely. Absolutely. I'm savage. I like ammunition. So,
take this, mean bitch.
That's the thing, is that Eugene has got he's got points about things that need to happen to bring. It's the greatest alt stream experiment and one of the greatest mainstream experiments ever done, and it's got to be brought into alignment. This isn't Ramon's. I can write whatever kind of paper I like as long as I cite it and bring it on. We want to get this into IEEE. We want to get this into Nature. We want to get this into phys.org. The only way that's going to happen is if they publish.
Yeah, period. And well, I mean, I go back to Monty when he said that they broke the brain of the physicist looking at the data. That is a new plasma physics that we're entering into. That this is a new era of plasma physics where all of the old rules don't apply anymore, and this will change everything if they can open up into the standard plasma physics. Wow.
Yeah,
then that's going to be big.
They got to be willing. They got to be willing to take that scrutiny. I mean, it's hard, but it's the only. It's like kind of becoming a heavyweight champion of the world. There's only one way to do it.
I did mention that MIT is putting together a Sapphire-like project based on what Monty went and told them about it, because Monty went to MIT and had a talk to them about Sapphire and low energy nuclear transmutations and all of that shit, and they decided, well, maybe it's time to look at this. So I don't think they're saying, well, yeah, it's the model of the sun. They're saying, what's going on here, and let's explore it.
However we can get them in the door, I guess. That's the
exactly. That's my thinking too. Even if they don't think it's the model of the sun, that they think something else is going on, at least it gets them building and thinking about it and talking about it, and perhaps the change will come soon after that.
Well, God blessing it will. I think it will. Listen, I wanted to ask you guys before we head off of here. Is this something that we want to repeat every few weeks? That'd be pretty cool. We could drag a few people in. I was hoping that Roxy would bring her partner. Apparently, he's big into plasma electromagnetism. So I hopefully will get a new one. I did post in the Discord, Rick, but I didn't get anybody to email me back.
I mentioned I was talking to Greg half an hour or an hour before.
I added him to the group. So
he wanted you to get together with you, by the way, and do that show that you wanted to do.
We will. It'll probably be this weekend. He likes to be up late, and I don't like to do shows that late. I like to do them a little early so I can watch my stuff and fall asleep on the couch or whatever. But speaking of which, 'tis that time for me to go up and stare at the screen and get my electrical connection and then pass out on the couch. I had a good time, and I hope people like the slideshow. And certainly, buddy, you can cut this up into whatever you want to do for your channel. It's fine by me. Just don't put my last name on the video title. Just put Sherfu Ramon, and then you can use the different sections. guys, I really appreciate you showing up and showing me support. That's really great. Thank you.
Yeah, I'd love to grab a copy or a link or something like that at some point, because and next time I'll invite my father to come along too, because he loves these kind of conversations.
Great. At some point, I still haven't done. No one on no show have I done the futurism, the Birkeland polyphase superweb stuff. So I'm hoping to do one of those. Maybe we'll do it. Maybe we'll do it here. But guys, again, much appreciated, and stay well, stay safe, and keep spreading the good word, I guess. The gospel truth.
Sapphire will win the battle.
So, buddy, if you're there, you probably should hit the stop recording the call. I hope he's there. What happens, Rick, if we hang up and he's still recording? Does it just keep going until he comes back?
Yeah, he just keeps recording until he shuts it off, until he comes back to the phone and nobody's here.
Oh, okay. And then it'll post the link in the Meme Machine group, I believe. Once
Once he shuts the recording off, it should put a little thing. Here's the recording. It'll be available for however long, however many days, whatever. Yeah.
Okay. Great.
You should be able to download it as soon as he.
All right. Well, then we'll all head out. Buddy will discover we've already left the lobby.
Roger that.
All
right. Good night, fellas.
And Aaron, your microphone, whatever you did, that last little. Oh, he left.
Yeah.
His microphone was terrible there. Oh, Aaron, you're back. Whatever you did, that last little bit, your microphone was a lot better. Right at the end, but while you were talking, it was brutal.
Yeah, it was pretty brutal.
My apologies.
Oh, no worries. Yeah, that sounds fine. Okay. All right, guys.
Yeah, no, I was just letting you know so that, for the recording purposes and, for a YouTube show, you might want to be heard a little better. That's all.
Yeah. If of course, I probably Buddy will parse this down a bit, but anyways, have a good night, fellas.
Yep. Right. Thank you.
Yep.
Take care, guys. Buddy, time to wake up. Time to go. Anyways, buddy, have a good night, bro. Take care.